By the end of this video, you should know 3 more things about vectors. First, vectors of the same type can be added. Vectors of the same type can be subtracted. And vectors can be multiplied by scalars. In the previous video, we talked about a ship sailing on the ocean, and we talked about the ship's displacement. Now we're going to discuss a boat and the boat's velocity, not just its speed, because we're going to assign a direction to this boat as well. So this red arrow indicates that we have a magnitude of some magnitude here. We're not going to get into numbers yet, but we definitely have a direction. That direction is perpendicular to the new vector that I have drawn, and this is drawn to indicate the current of a river that this boat is trying to cross. Since we are using the polygon method, also known as the tail-to-tip method for adding vectors, I'm going to move the tail of my current vector to the tip of the vector indicating the velocity of the boat. Now, I could also move the velocity of the boat vector so that its tail is at the tip of the current. That gets me into my writing up there, so I can move both of them in this fashion, but I'm going to go with the way I originally set them up. The resultant will be the same, no matter which one you add first, because just like 3 plus 4 is equal to 4 plus 3, vector A plus vector B is equal to the same resultant, no matter what order you add them in. And that resultant is going to be, I'll call it vector R, which reaches from the tail of vector A to the tip of vector B. When this boat is set in the current, if the boat heads directly across the current, it will not actually arrive there because the current will act upon it and its direction and speed will have changed, and it will be the velocity indicated by this arrow, resultant velocity, vector R. We have added these vectors. Vector A plus vector B equals vector R. You can add any vectors of the same type. You can add displacement vectors, you can add velocity vectors, you can add acceleration, force vectors, momentum vectors. Any type of vectors can be added using this method as long as they are the same type of vector. I also told you at the beginning of the video that vectors of the same type can be subtracted. So let's see what happens if we investigate A minus B. What will that equal? I have zoomed out a little bit, so let me make this a little bit bigger again. The proportions have remained the same. Now, remember your algebra. When we're working with vectors, you have to remember your algebra, your geometry, and your trigonometry. Remember that when you are subtracting something, it is the same as adding its opposite, or adding a negative. So we're going to add A and negative B, but wait a minute. On my screen, I still have the original vector B. So let's move this out of the way, take the label with its arrow, and let's put in here the negative of vector B, or the vector that goes in the opposite direction. That's going in the opposite direction. It's obviously in the wrong place because it's tip to tip here. Let me first label it as negative vector B. And let me group those two. Hang on just a second. Now I can move it to the proper position, which is with its tail to the tip of the first vector. Now we have a new resultant vector. I have labeled our new resultant vector S, since R was already taken by the addition of A and B. So A minus B gives us vector S. And finally, the last point, vectors can be multiplied by scalars. Let's take a look at vector C. And let's take vector C and multiply it by 2. 2 is a scalar, it has no direction. So 2 times vector C. The magnitude of a vector is a scalar. So when you multiply a vector by a scalar, you are multiplying the magnitude by the scalar. In this case, 2 times the original length of C. Here's 1C, here's 2C. So this is the vector 2C. Want to go for 3? Just add another copy of vector C. You may have noticed that 3 times vector C is the same thing as vector C plus vector C plus vector C. Of course, scalars are not always whole numbers. 1/2 is a scalar. There is no direction attached to it. It is a magnitude. And 1/2 of vector D would give us this. The direction is the same. The magnitude is halved. So remember, vectors of the same type can be added, vectors of the same type can be subtracted, and vectors can be multiplied by scalars.